Hi, welcome to my video tutorials on math facts. We're starting with a unit on rational numbers, and the first topic we are going to be spending time on is prime factorization. So let's take a look at what that means. Well, what are factors? Factors are numbers that you can divide another number by evenly. For example, the factors of 32 would be 2, 16, 8, 4, 32, and 1, because you can divide the number 32 by any of these numbers and get a whole number as an answer. What are the factors of 50? They would be 1 and 50, 5 and 10, and 2 and 25. All right, so what is prime factorization then? Prime factorization is when you factor a number over and over until only its prime factors are left. Prime numbers can only be divided by 1 in itself. So some common prime numbers, 1, 2, 3, 5, 7, 11. These are all numbers that cannot be divided by anything else. In order to find the prime factorization of a number, we use a factor tree. Here's what that would look like. So if we factor the number 40, till we get its prime factorization, we would do it this way. We would start with 40 at the top of our factor tree, and we would branch off into just two factors. So the first two factors of 40 that came to my mind were 4 and 10. All right, 4 times 10 gives you 40. So you could pick any two factors of 40 you want to. It doesn't have to be 4 and 10. But then we would factor these two factors further. So 4 can be factored down into 2 and 2. And 10 can be factored down into 4 and 5. Now all four of these factors are prime. Right? None of these numbers can be divided by anything other than 1 or themselves. So these are the prime factors of 40. And if you were to multiply 2 times 2 times 2 times 5, you would get 40. All right? So to express that, you could write it as 2 times 2 times 2 times 5, or we can use the exponent 2 to the third power times 5. That's the prime factorization of 40. All right, clear my ink up, and let's look at the next page. We're going to practice finding the prime factorization of these four numbers using a factor tree. So let's start with 16. 16 can be factored down into 4 and 4 are the first two factors that spring to my mind. You could have done 2 and 8. It's up to you. Then 4 can be factored into 2 and 2. Both of our 4s will be factored into 2 and 2. And that's it. We're down to our primes. So 16 can be expressed as 2 times 2 times 2 times 2, or using the exponent 2 to the fourth. That's our prime factorization. 25 can be factored down into 5 and 5. And that's it. That's as much as you can do. So 25, the prime factorization is 5 times 5, or 5 squared. 81 can be factored down into 9 times 9. And 9 could be factored to 3 times 3. So we could express the prime factorization of 81 as 3 times 3 times 3 times 3, or 3 to the fourth power. Okay, 122. So 122 is not automatic to me, but we know that we could divide 122 by 2, so we can factor it into 2 and 61. All right, now 61 might be a prime number. In fact, I'm pretty certain that it is. So we could say that the prime factorization of 122 is simply 2 times 61. All right, that's it for prime factorization. Thanks for joining me. Take it easy.